Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to another video of Chem Solve. Today we are going to start a new topic of organic chemistry series, and the topic is carboxylic acid. So let's move towards the topic. Let me write the name of the topic first. The name is carboxylic acid. Okay, before understanding the term carboxylic acid, of course we need to understand the definition. So what is the definition of the carboxylic acid? Carboxylic acid are basically homologous series of organic acids which have the carboxyl, what is that? COOH functional group. So how do we will recognize that this organic compound is a carboxylic acid? The answer is presence of this function group. If any of the if any of the organic compound has this function group, it's mean it would be a carboxylic acid. Let's understand the journal formula of carboxylic acids. So the journal formula is CnH2n plus 1 COOH, where you know N is the number of carbon atoms in the given carboxylic acid molecule. There is very important point to remember while writing the formula of the carboxylic acid, and that is always choose the N one less than the actual number required, because 1C is already present in the formula, that is COOH. So in short, 1C is already present in the formula. That's why we will always choose one carbon less. Let's understand it with the help of few examples. For example, if I need to make ethanoic acid, now I know that eth is equal to carbon number 2, and the journal formula is CnH2n plus 1 COOH. So if I will place Cn is equal to 2 here, because C is 2. We are going to prepare ethanoic acid. So C should be, the carbon number should be 2. So if I will put 2 over here, so it would be 2 2s are 4 and 1 plus 1 5 COOH. Now count how many carbon atoms are there in total. There are total 2 and 1. 3 carbon atoms. So it wouldn't be ethanoic acid. Okay, it wouldn't be ethanoic acid. Then what I have to do? I will have to choose 1 carbon less. So instead of 2 here, I will write C1 or C1. No need to write it. H, 2n plus 1, that is CH3 COOH. Now look, how many carbon atoms are here? 1 plus 1, 2. This is ethanoic acid. Yes, I hope you have understood the whole concept. As we have discussed earlier, of course, the function group is C double bond O, OH, or we can also write it in this way. Okay, how to name carboxylic acid? Naming carboxylic acid. For that, we simply have to add the word oic acid at the end of the name. All right. So let's write down some of the names and the formulas of few carboxylic acids. So let's start it. In first column, I will write name, then molecular formula, then structural formula, and lastly displayed formula. Okay, so how to write down the name? The first carboxylic acid has carbon number 1, so I will just write carbon 1, that is already the part of the molecule, so I will just have to put H over here. What would be the name? Methanoic acid. What did I do? It is methane basically, so I just cut E and the name would be methanoic acid. Understood? Similarly, the structure formula would remain same, while in displayed formula, we have to show all the atoms and all the bonds, so it would be like this. Let's show it as well with the help of one bond. My bad. Like this. Okay. So when carbon number are 2, then C H2N plus 1, that makes 3, and at the end COOH. The name would be ethene. E will be cut down, and oic acid, right? And structure formula will remain same, but for displayed formula we have to show all the atoms and all the bonds. Okay, so next is carbon number 3. So instead of 3, I will write down 2, H2N plus 1, that make 5, COOH at the end. Okay, carbon number 3 is propane. So I will write propane, but E would be erased and add oic acid. Similarly, if carbon number is 4, it means I have to put one carbon less, and that is C3 H2N plus 1, that makes 7, COOH at the end. Carbon number 4 is butane. We will omit E at the end, add oic acid. So butanoic acid, and the structure formula would be CH3 CH2 COOH, and here it would be CH3 CH2 CH2 COOH. For displayed formula, we have to show all the atoms and all the bonds like this. For this, we have to draw 4 carbon. The last one is the function group, and for rest of the carbon, I will attach hydrogen atoms which are required. Okay, I hope you must have understood that how to name the formulas and how to write the names of different carboxylic acid. Now coming towards the next topic, that is preparation of carboxylic acid. Okay, so my dear student, let's understand first carboxylic acid or ethanoic acid, the simplest carboxylic acid, is a colorless liquid at room temperature and pressure, and have characteristics smell of vinegar. While vinegar is a dilute solution, about 4% of ethanoic acid and used in food preservation and for flavoring. Okay, so there are basically two ways for the production of or for the preparation of carboxylic acid. What are these two ways? Number one is oxidation by acidified potassium manganate 7. Okay, we know that this thing, it is an oxidizing agent. So what happened? When a mixture of acidified potassium manganate 7 and ethanol are heated, it changes into ethanoic acid. Okay, so let's understand that how does it happen. So basically what happens that ethanol plus oxygen from oxidizing agent they are being heated and it converted into ethanoic acid plus water. Okay, we will understand it that how does it happen, but before that let's look at this picture. So we have So this is the whole laboratory setup for the production of ethanoic acid. So what happens? Here we have potassium manganate 7 plus ethanol in this test tube. We are gonna heat it and the oxidation take place. We collect the ethanoic acid here in this test tube, and this is the cold water. So this is the whole laboratory setup for this process. Now look at the balanced chemical equation. In the word equation you can see I took ethanol, so I'm gonna take ethanol here. Ethanol is 2 carbon and 1 alcoholic function group. Let me complete all the hydrogen attached with these carbon, and this is the oxygen from the oxidizing agent. So what happens? This thing will remain same. So I'm just gonna write 2 carbons and their respective hydrogen here. One oxygen will be added here and this OH group will remain at its place. So what happened actually? We just removed these 2 hydrogens from here. So let me write these 2 hydrogens. They will be H2, and instead 1 oxygen is being moved here, and we are left with 1 other oxygen, that is H2O. Okay. So let's understand the equation again. We just remove this hydrogen and this hydrogen and it make H2O, and instead one oxygen is moved here. So there would be an oxygen here instead of hydrogen. Rest of the thing is remain same. Like this is CH3, this is CH3, this is OH, this is OH. The only change that took place is at this point. At this point, these 2 hydrogen are being removed and this oxygen is being added. So removal of the hydrogen is called oxidation, And so we can say this is basically a redox reaction that took place. Okay, I hope you must have understood. This whole part remains same, like this OH remains same. You can see the only change is this C double bond O, while here it was CH2. So H are being removed and they are here, and one oxygen is being added, which is here, and one oxygen is the part of the water molecule. Okay, and that's it. Next preparatory method is called oxidation by atmospheric oxygen. Okay, so the equation is almost same. The only difference is that now we are not going to provide the oxidizing agent. Instead, the atmospheric oxygen will oxidize alcohol. So how does it happen? Let me write the equation again. We have ethanol and I'm gonna add oxygen here. What will happen? This hydrogen and this hydrogen are being removed, and one oxygen will move here. So resultantly we would have C H H, H will remain same. There would be C double bond O instead, and this OH will be at its place. Like this. So simply it was Ca3 CH2 OH plus oxygen and it will turn into Ca3 C double bond O OH plus H2O. So can you see the only thing that I changed is the removal of this H2 and the addition of this oxygen, and that's it. I hope you must have understood the whole concept. Till now we have covered the definition, function group, and the general formula of the carboxylic acid, and also the production of the carboxylic acid, particularly ethanoic acid. So in the next video, inshallah, we will discuss the chemical and the physical properties of the carboxylic acid. Thank you so much. Allah Hafiz.